nothing. She's not even here. So I just did nothing all day. Oh, it's unit 6.
We're on skill 6. I know, we are. Alright guys, we are doing trig proofs. Guys up here. Something like that, 12, right? 13. Some are longer.
Oh yeah, I forgot how to get it.
It's okay. Alright guys, we have some rules for our trig proofs, okay? These are different than geometry proofs. It's not like a statement and a reason and lists like that. They're algebraic. You sort of are just working your way through to prove that one side of the equation equals the other side. But it's all with trig stuff and trig identities and things like that. So, your rules. The first one, you can only work on one side. So you can't like simplify both sides of the equation to make them match. You work on one side until you've turned it into the other side. All right, second rule, you cannot cross the equal sign. You guys know in algebra you have your properties of equality, like solving an equation, you might add 2 to both sides or multiply both sides by 3. You cannot do that in a proof because you don't actually know that they're equal. You are proving that they're equal, so none of those properties of equality hold. Did we just hear the word proof for the first time?
No, we have to do that stupid thing where it's a chart and you have to like write everything.
But they're not like geometry proofs.
Well, I hate geometry proofs. Is this going to be bad or no?
Well, they're different than geometry proofs, but
Good enough for
it's still like logical, step-by-step thinking.
Do I memorize the properties like?
It's not like geometry properties. There are some identities that you'll have to learn.
But still, you can't not logically do math.
Agreed.
It all has to be logical.
Yes.
But geometry proofs, you're not crossing the equal sign. You're just working on one. Do you choose which side you're working on?
Yes.
I have to write like
Yep.
syllogisms of whatever and something. You get that. You were telling me that you started doing class.
We have to do something.
Do not sit and stare. Okay? Yep, the sit and stare approach gets you nowhere. Don't do it. Try something. If it doesn't work, maybe it'll trigger something else for you to try. With these proofs, it's okay if you start down a path and you get partway through and you're like, oh, that's not gonna work. That's not what I need to do. And you go back and you start over. It's okay to make a mistake. I know that's hard for some of you. Like you don't want to write it until you know it's right, but you can do it.
That's an easy way to get very personal skills.
That's very true.
Right?
Sounds like we're all going to be getting very mad this unit.
All right, so those were your rules. Now I'll give you some strategies, okay? I know. It's kind of like that. They are like little puzzles.
I do love puzzles though.
Well, then you might like them.
Honestly, I don't know. I like yes, I don't like graphics. That's like what's not funny.
There is no graphing in this skill.
Yes.
Right? Happy day,
That's,
right?
we like hearing what you do with numbers. That's why I yes.
Okay, guys, so here's a basic proof. What it might look like.
So you're just gonna give us all the rules and strategies, and then we go to the problem.
So with each strategy, I'll show you an example of using that strategy. Okay. All right, so this is a basic one. Tangent of x times 1 over cotangent of x equals tangent squared of x. Okay? That's, so obviously different than a geometry proof, right? Okay. What you're going to do is essentially simplify and rewrite along the way until one side equals the other side. So what is 1 over cotangent? That's just tangent. So this is really tangent of x times tangent of x. And guys, I usually draw a line here under the equal sign as a reminder, like don't cross over that. Stay on your side, stay in your lane, people. What is tangent times tangent?
Tangent squared.
Okay.
And 1 over.
You have successfully completed your first proof.
Wow. Oh wait, so that didn't look
Better than graphics, right?
Oh.
Okay, well, slow with the gears this morning. You got what?
Completely behind that.
Okay. You want me to wait a minute
So
here?
I should have had,
Do you not have classes or is
This week and it's coming on Tuesday. My
Oh,
grade
okay.
Friday.
we have vision?
It's felt like Friday every day. And it finally is.
It's been misleading every day.
All right.
We made it.
Second strategy.
oh my gosh.
Split up a fraction.
No.
Is it the word fraction that caused that reaction?
Yes.
Okay.
Did you ever feel like we bad job taking this how to do fractions for like elementary school and it has come back to haunt us every time? Like, they just did a terrible job.
She also said she was confident in my ability to get
Like, literally. Yes, because they just.
All right, guys, there's your next proof. Secant of x minus cosine of x all over cosine of x equals tangent squared x.
So cute.
Wait, I think you just like
You can split them up and then you put up the cosine.
Sure.
Yeah.
I'm trying
So you have secant over cosine.
Yeah.
Would be allowed to make that work.
Secant minus cosine is not 1.
No, but can't you make second like 1 over?
Is that
Oh,
yeah.
Wait, on this way.
Yeah.
tangent squared. Yes. Yeah, guys, I forget that that's weird to you guys. You expect to see like that, right, for tangent squared. It's not how we write it. That would be like the x's squared. So if you see like the whole thing squared, that is written like that. Okay, just so you're aware. Sorry, I should have explained that more in the first
Using
one.
numbers for math.
You what?
There's not a single number other than
There's a 2.
It's a 1.
other than the
There's
x.
a 1.
I numbered the problem.
That's true. There's another 1 and 2.
It's the number you
We'll have 3 soon enough.
We will.
It's not okay.
counting.
I guess we're too old for having numbers. Now we just get a bunch of letters.
Problem 2 when there's 1 minute left.
Okay.
Yeah.
Splitting up your fraction here. Now, Jane, you asked, could I rewrite secant as 1 over cosine? You absolutely could. With these proofs, there's lots of different routes you can take. Some of you will see the most efficient route. Others, you like the scenic walk, and you're going to take a long time to get there. You can still get to the same endpoint, and that's okay. When I grade them, I just look at what you did and see like, okay, yep, all right, we're taking the long route, but yes, we made it. Like, I look at every step you do, okay? So, this one, what we're gonna do to split up into a fraction, when you have a single denominator, do you guys know this, that you could write this as 2 fractions?
Yes.
Yes.
Okay,
I know that.
somehow,
And then the cosine can that just be 1?
yes.
Cool.
Wait, that equals
But then
what?
how do you make it?
I will show you.
Oh dear.
Are we okay with that first step? Yeah. Okay. All right.
When you
Algebraically, make sure what I'm doing is making sense to you. Are we good with that?
Yeah.
Okay, let's stop for a second. Secant over cosine is secant times 1 over cosine, right?
Well, why does that help?
Yes. I will show you.
I see where this is headed.
I have absolutely no idea.
I will show you.
I get it now.
All right, the gears.
They're the rest of the time.
That moment when they were when a foreign characters walk out towards Baghdad.
That's where we are, right?
This is when you just turn around and walk out. Like, this is the time to do it.
I'm on board.
Okay, algebraically, I know you guys don't see where I'm going, and you shouldn't yet. That's
Oh,
okay.
absolutely not.
But do you follow the algebra? Okay.
Oh! Is that secant?
That is secant times secant.
Secant squared feels
Okay.
Are you gonna get something?
So that is secant squared x minus 1. Okay. We're going to pause on this, and I'm going to teach you Pythagorean identities, because that equals tangent squared. And you're like, what? How can that possibly be? It is. So let me show you Pythagorean identities. Not those.
Oh,
Okay.
What? Rewrite it all for you. Can, yeah. This is something, you might even want it on like its own little happy, you're going to reference it all the time kind of page, okay?
No, I never want to see
What is,
Wait, how much space?
oh, sure.
I didn't even like link it.
No, I'm just working on
That's what I'm going to show you.
I
That's the excitement that's coming.
I study cosine is also I just study.
Wow.
I was at one of them.
Pythagoras.
Yeah, screw that guy.
Oh, like, yeah, he's the reason we're here.
Pythagorean?
Pythagoras.
Pythagoras like makes everything easy. I don't know what y'all are talking
He's the reason we have to learn this stuff.
about.
He just never found it out.
Okay, you should be familiar with that little triangle in a circle, right? We've drawn this before. I know you can't see Adam. It's an X, a Y, and an R. Yes, okay. There's a theta in there.
I only kind of know.
There's so many letters in that now.
Oh, there's not three letters. X is sideways. Y is up and down.
There's
Radius.
There's so many variables. We have to switch.
Okay.
Have enough letters.
Whatever you say. Got an uproar on my hands today.
Oh yeah.
Okay, do you guys agree?
No.
Well, sad day for you.
Saturday.
Yeah.
Okay.
Isn't it X squared or A
What?
squared?
Well, I don't see any A's, B's, and C's. Are we okay? X squared? Yeah, so we're done? Yeah, no, we're not done. Okay.
Give me like 3 seconds.
Okay.
That we're ahead
Of what?
of like
Because I'm 1 and 2.
In class today or for the year? We're on schedule. Okay.
But yeah, how much longer are we doing trigs?
A long time.
The rest of the year,
No, we have calculus at the end, but I've ruined Adam's day.
and the rest of the year.
Okay, guys, with your trig stuff that we did, think back to the unit circle. What did x represent? Like in the order, yes, cosine. Okay, so x squared is going to be.
Oh.
Okay. What is the y going to be? Sine. And what is r in our unit circle? 1. This right here is the most important Pythagorean identity for you to know. You must know that. You will see it all the time. Okay. From this one identity, we're going to get 8 more.
As soon as I got scared. We just everything out of it, aren't we?
Yes, we're going to rewrite it.
Yeah, no,
in that
bottom
way.
gets stuff free.
Yep. It's like a punch card, guys.
All right, people know that and must know that.
I know, that's
I'm gonna tell my grandma about this and she's gonna
Sounds alright.
All right, what if I solve this one for cosine squared? What would it equal?
I don't know.
1 minus sine squared. Okay. So that wasn't like a big leap to get that one, right?
It's a long jump.
That is also an identity. And what if I had solved for sine squared theta? 1 minus cosine squared theta. Okay. So we're going to kind of clump those with that one.
I really don't appreciate it.
I think we should say
Guys, without these, proofs will be so hard. These are like your little substitution tools that make them easier. Well, without these, you'll just be stuck. You'll just be like, I don't know.
Cool. Sounds good.
Okay, I'm going to rewrite the original one again over here. So cosine squared theta plus sine squared theta equals 1.
we have to.
Separate those separate.
Oh, well, I don't know where I'm going or if this is happening.
I don't know.
Okay. I'm going to manipulate this by dividing everything by cosine squared. I'm not changing the value because I'm dividing everything by that, but I'm going to take each term and divide it by cosine squared.
Oh, this is pretty good. But
Mentally,
Yeah.
when you're describing it, you bother saying cosine squared and very
I usually just say cosine squared. You should probably say the theta. You definitely have to write the theta.
Yeah.
It's wrong if there's no angle there. If you just write cosine squared, nothing is not right. Okay, so let's simplify these. What is cosine squared over cosine squared? 1. What is sine squared over cosine squared?
2.
Tangent squared, not 2.
Where did we get this? Oh.
Y over x. Yeah, okay.
That's not.
Equals secant squared. Yes.
I don't know. When I hear secant, I think of photons.
Oh, interesting.
When you hear secant, you think of
Yeah.
That's it. I've never heard that one. No one has ever said that.
He's a little special.
When he hears secant, he thinks of pecans.
Pecans. Wait, that's
Well, and
so
how do you
true.
say?
When you say pecan,
Pecan, pecan, con. Okay, so that's another main trig identity here. Let's solve it for other things. What if I solve it for 1? Okay. What if I solved it for tangent squared? Secant squared theta minus 1?
Oh, throwback.
That's the one we were actually using in our problem.
It's almost like it was
They're all identities, yeah. So, guys, what you do with these, there are different substitutions you could do in a proof. So, like, if you see a tangent squared in a proof, you might go, oh, hey, I want to substitute secant squared minus 1, because then that leads me to this. So, knowing these identities helps you recognize what you could plug in to make one side equal the other
Let's
side.
get easier.
Yes, the more you use them, the easier it gets. Finn.
Going back to the cosine to getting to the tangent squared of theta.
Yes.
Isn't it y squared over x squared?
Yes, which is tangent squared.
Right.
Because that'd be like opposite over adjacent.
No, I got that because it was y over x.
Yep.
It's the square you would say.
Yep. All right, guys, one more round of this. What do you think I'm going to divide by this time? Okay. Pausing.
Yeah, wait,
I'm kind of far behind, so. There's a lot of data. It's kind of hard to draw. Alright, I'm good.
Okay. Push play.
So would that be
So what do you think cosine squared over sine squared is? Yes. The cotangent. Sine squared over sine squared?
1?
One.
divide sine is like
Because I already did cosine.
oh,
So I picked the other one.
I'll say I was like
And then what's 1 over sine? Yeah. Okay.
CSE, that reminds me of like a keyboard.
My dad.
Yeah, like escape. Escape.
All right, and again, solve for each thing here. What would cotangent squared be equal to? Yeah. What would what be equal to? Okay. Now we can use these.
I guess we like a quick recess.
Take a breath. Yeah. Whatever, for whatever reason, like this side of my thing, I can't write on. It's just like squiggles. So you can almost read my cotangent squared. Yeah. Okay. So back to the one we were in the middle of.
no, I think we're good.
Adam!
I think we're
How
done.
many times do you write this?
You're just done.
In a day or in my life? Like my 19th year teaching pre-calc. I've written it a lot. Cotangent squared.
Wait, so then, are we supposed to like memorize?
No, so yes and no. Sine squared plus cosine squared equals 1. Yes, that should be in your memory. You could easily derive the others from that, like with what we just did. But the better you know them, the better you'll be at using them in the proofs, because you'll just be like, oh, that's a thing. Like I can substitute for that. But if you don't know them, you're a little slower to recognize them. So yes and no.
I didn't really agree with the question was, but do you think we should like? I didn't get the question. Should we try to like compare on it?
That was the question.
It was the question.
Yeah. So the better you know them, the easier the proofs are. So yes.
Yeah.
So kind of yeah. If you want to make your life easier, at least know like those 3 I put in the boxes, because you could easily manipulate those.
But like the past two.
So
Or like the one with the squiggles.
Wait, was that it? Like the
so this guy, this guy. I mean, my boxes and squiggles aren't they?
Is that into the diagram I did?
Yes. So back to this problem, guys. Secant squared minus 1. Is that an identity?
We haven't even like finished that equation.
We have 1 step left.
It's just again, it's not physics.
It's just tangent squared, right?
Yeah.
Okay. And then you're done.
Cool, we're done.
With these identities, you just use them. It's not like, oh, that's an identity. Let me prove it in the middle of the proof. No. You just use it. Use the substitution.
Where are we?
Okay.
Oh, we want that.
So that's our final step on that one.
Wow.
We'll figure it out.
We'll get
We
there.
just have to go on
Let me give you all the strategies, and I'll
How
definitely
many
give you some.
strategies are there?
6.
Oh, look, we've gotten to 2.
We don't have to pause and do a bunch of identities in the middle.
That's true.
All right, find a common denominator is a strategy.
Wait. Oh.
It's gonna get to a point where you just pick one strategy and try to do it.
Yeah, like you'll get to the point where you look at it and you're just like, okay, I'll try that. Or if you're like, I have no idea where to go, but hey, there's a fraction. I'll try that. Like sometimes it's just trial and error until you see where you're going. All right, tangent of x equals cosecant of x over cosine of x minus cosine of x over sine of x. Hey guys, I've just been picking the side for you. Which side do you think we want to work on this time? The right. It's usually the side with more stuff is the one you want to work on. Okay. Then, you know, whatever you think will be enjoyable.
Oh wait, no, never mind.
Okay.
Looking at the minus sign of the equal sign.
Oh, okay. Okay.
I got real.
Why what? This is just a problem given to you. Yes, this is just how it is. Okay. My strategy I told you for this one was to find a common denominator. So on the right side, what would your common denominator be? Cosine times sine, right?
Yeah.
I didn't say it was pretty, but that is your common denominator. So if you had a fraction of 2 in the denominator and 3 in the denominator, what's your common denominator? Multiply.
Would it be, couldn't you separate the second one into, could you make it cotangent of that?
You could, but that's not going to lead us to tangent necessarily. Yeah. All right. So think about, you don't have to write this, but just to make sure you see what we did. What did I take the first fraction times? Sine over sine, okay? You don't have to show that. In this one, I took times cosine over cosine. I just want to make sure everybody's with me on that. So this first piece is going to be sine of x times cosecant of x minus cosine of x times cosine of x. Okay, there's your lovely combined fraction. Yes, so sine times cosecant is 1 minus, what is cosine times cosine? Okay. Still over the lovely cosine of x, sine of x. And yes, you have to write that in every step. Guys, when I grade these, it's not like the final step is your answer. Your answer is everything you do the whole way through the problem. Sounds real fun for me, doesn't it?
Where is that one from?
The first one, sine times cosecant, they're reciprocals of each other. Yeah? Okay. All right. Pythagorean identities. Anytime you see something squared, your brain should just check, is that a Pythagorean identity?
But you're going back to like the first bit. How did you get that? Like sine of x, cosine of x.
Sine squared.
Also, they have the same denominator. Like you just write sine of x, cosine of x.
Yeah, that's what I multiplied by to find the common denominator. Sine squared, yes.
And then you get sine over cosine.
Beautiful.
Okay, everybody okay to sine squared over cosine sine? Pythagorean identity, and then can I cancel out a sine? Yeah, so that's gone. One of these are gone. What is sine over cosine? Tangent. And look, where were we going on the left side? tangent. We're not going anywhere. Yeah.
How is sine of x times cosecant of x 1?
Isn't cosecant 1 over sine? Right? Isn't that sine times cosecant?
Yeah.
Okay. Yes. So like any of those that are reciprocals of each other, when you multiply them, they're just 1. So like cosine times secant is going to be 1. Tangent times cotangent. Okay. All right. I was going to ask how are we doing, but I don't know that I want the answer.
I'm actually pretty good.
Okay.
Did we not do that one?
Do we what?
Are we not doing anything on the left side?
You only rule 1 work on one side. Rule 1 or 2, I don't remember which rule.
Ah, okay.
Yeah.
I did pretty much.
But we do on the other side.
What?
We do on the other side. We just like add this.
Like if you wanted to do the left side, you'd have to turn tangent into like sine over cosine. You'd essentially reverse these steps. It'd be a lot harder. It's less intuitive going backwards. So yeah.
I'm a little slow today, but on the going from the 1 minus cosine squared of x to the sine squared of it, how does that work?
That's a Pythagorean identity. Do you see 1 minus cosine squared is equal to sine squared? It was one of the first 3 you wrote down.
Oh, we have to have that correct.
Yep.
Are we writing any more about something like that?
Nope, that was all of them. This one's a short one.
No judgment. It's 2022.
Feels like he's calling her.
You can be a wolf.
All right. Rewrite with sine and
Can you
cosine.
go back to like 1?
Oh, sure.
Okay.
There's several ways you could do this one. So,
Isn't it just tangent squared?
no.
It's tangent times cotangent.
That is one way you could do it. Or, what could I turn tangent? Yeah. Either of those are fine.
It is.
We missed the
What?
Oh, so I'm just wrong.
So
Cosine over sine is cotangent.
cotangent.
Yes, Finn.
Kenny.
For the when we talked out the sine of x,
Mm-hmm.
what can you just like think of?
X squared over x, what would that become?
So would you just use sine of x over cosine of x?
Mm-hmm. Which is,
Oh, you just do that on one side.
I did.
Okay.
All right, guys. Again, multiple ways you could do 4. If we rewrite the tangent as sine over cosine, you can see cancel, 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 cancel. 1 equals 1.
Oh, I didn't see that.
Different kind of. Okay. You absolutely could have turned cosine over sine into cotangent and totally fine. Yes.
Oh, so that works too.
Yes. There are so many of these with lots of ways to do that. I've got 2 more strategies, but they're actually pretty short too.
You said it was the last one.
No?
Two more. It was the first.
Okay. All right, we've already been using this one, but use Pythagorean identities.
Missed the thing.
Yeah.
For the one you just did with like the right part of it, you just cross out all of it.
Yeah. The one sign doesn't look like it got crossed out very well. I missed with my line, but yes. I know, you've already been doing it. Now you're officially doing this. All right, let me break that up for you. We've got cosine squared plus sine squared equals cosecant squared minus cotangent squared. Doesn't really look like they're equal, but they are. Okay, I'm going to do this one on the left. What is cosine squared plus sine squared? 1. Okay. Look through your Pythagorean identities. Does 1 equal anything helpful to us?
Cosecant minus cosine.
Oh, look at that.
Oh my god. This is nice.
Cosecant minus cotangent equals 1.
What do you mean?
So you couldn't change both of them to 1?
No, you cannot work on both sides. In honors, we make you work only on one side.
Wait, so in non-honors,
Non-honors, they'd be like, oh, 1 equals 1. And,
Are you serious?
What?
Just take it off.
so they just.
It's
Oh
okay.
yeah,
Great.
the gas thing.
Great boost for the CPA. I also didn't get a point. I didn't get a chance. I didn't get a There was no choice involved.
you don't want to leave this class.
Because we need to improve this.
I didn't get a choice. Parents were like, you're
And it's to stimulate
I would have trash it up.
Do we see it, guys, that this is just a Pythagorean identity? So we're replacing this with a 1, and then we're replacing 1 with this.
Is that equals 4?
Yes.
what that equals.
1 more zero.
So you're basically what you're doing is you're gonna take this thing, and then you're gonna make it equal to 1, and then you're gonna make 1 equals to another thing.
Yeah, you just keep substituting until you've made them match.
Just keep going.
Like a little puzzle. All right, 6th strategy, factor.
I do love factoring.
I got some.
This one's pretty short too. Not maybe one more step than last one. All right, cotangent of x minus cotangent of x times cosine squared of x. Question equals sine of x times cosine of x. Which side do you think we're working on? Good guess. And since I said factor, it makes sense to work on the side that you could actually factor something out of. What could I factor out of the left side? No. Cotangent of x. See? Oh,
Oh my god, that's one of your things, isn't it?
you would be left with 1 minus cosine squared x.
Oh.
Isn't that a thing?
That's a thing, right? Okay. I see on the right side, it's just sine and cosine. So I'm going to turn the left side into sine and cosine as well. What is cotangent as sine and cosine? Cosine over sine. And then Pythagorean identity, what is 1 minus cosine squared equal to? Yeah, sine squared. Do you see any reducing I could do?
It's the square.
And then isn't that the same thing as the right? I'll write it in the right order. Okay.
We're done with the alternate. There were 6.
Well, then you didn't get there. I'm never going to give you proofs that aren't true.
That'd be really
Yeah. Okay. Yeah, no.
That'd be helpful.
There's enough going on in these. I don't need to be like, haha. Like, no. Either.
Can you explain how you got the cotangent x and then 1 minus cosine squared?
Okay, so what if I had 3 minus 3x? Could you factor that?
Yeah, I take out the 3.
Oh, and what would be left?
It's just 1 minus an x.
Okay. I took out a cotangent.
What's the next?
Now, are there like names for these properties that we have to memorize and then take this out?
Hey, can we just get a bunch
What
of
we've done is what it is. Okay? Ethan, do you see it?
What is this?
Oh, okay.
You good?
I think I get it.
Okay. Yes, okay, we're moving on to the you try part of the day.
Oh wait, those are some answers.
Yes.
Yeah, I like it at the end of
Square x. How do I say it again? Cos squared x.
Cosine squared x.
Okay, how does 1 minus cosine squared x equal sine?
Okay, you know cosine squared x plus sine squared x equals 1, right? I know, very soon. Let me write the first problem, and then I'll have you go out the hall. All right.
Thank you. That's what we needed to know.
Is what we needed today. Gotcha.
It's Friday. We have 2 days off.
I don't know what it is.
What are the chances it's one of the compacted
Oh, that's a square, don't mind.
Oh. I'm gonna draw a frowny face instead of a smile.
No.
I get it.
Y'all are going to scratch some of next one?
Is this a this is a new strategy or
Yep, sounds good.
Okay, this is fun.
See, they're like little puzzles, right?
It doesn't look like scratches, it looks like.
I think I'm going to sit
We do a weird thing.
No, sit and stare.
Not sitting there.
Okay. Good. We'll go through one of these.
9 over cosine?
It's not a real long one, guys. What?
Okay, starting off. Okay, I like that.
Yep.
Oh, that was easy. You're right.
Oh, is it gonna get like crazy?
Really? It's just like recognizing the substitutions. Every once in a while, there's kind of like an ugly fraction one,
I don't
but
like fractions. We shouldn't do fractions.
well, they're a thing.
Are they?
Are we ready, guys?
So, I'm getting,
They really are.
give you a little bit more than a second.
Yes, fractions. I don't have like.
You gotta show it. But, well, like, do you mean rewrite the Pythagorean and turn it into sine over cosine, all of that?
That's when I only did like 2 steps. Like I just did for the second row cosine squared x times sine.
Sine squared over cosine squared. That's fine. You can do that.
But like
You can't just be like this and then write sine squared. You know, like you have to show me something. All right. What is 1 minus sine squared? Squared. Okay. And tangent is
X, and you cancel the cosine.
They cancel, and we're done.
Wow, that was so complicated, Mr. Lee.
All right. Everybody good?
Yeah.
For now. We got number 1.
How many numbers are there?
I think I have 6 written down. We'll see what we get. I mean, there's a lot of these that we can.
But like,
All right, cosine squared x over sine of x plus sine of x equals cosecant of x. Ready, go.
Oh yeah, but I just opened. Oh wait.
Ariel, what are you working on? What are you doing? Do you have this done? You got number 2 done? Okay.
Okay, yes. Yeah, I think you might want to get some white out.
That's not going well there.
He doesn't even want the white out. You stole it from Mr. Cassette?
No, I asked if I could have it.
Oh.
I stole it.
I just wanted to say
I like this.
Are we ready, guys?
No.
Oh, okay. Sorry.
Thank you.
If I put this over 1, does that help you? You're like, nope.
You just gotta do it.
I'm like, I still have to. Okay, it was 1.
Because whenever you see exponents, you're
You're just like saying words.
Ooh. You can do this one in 3 steps. Feels like name that tune. I can do this proof in 3 steps.
Let's see who can get the least amount of steps.
Oh my goodness.
Wait, I'm on the right track. I think I got it. I 100% do not got it.
Are we all just happy we're not graphing?
Yes.
Where we are?
Yes.
Not, oh no, are you stuck on this?
Yes.
Common denominator.
I tried that.
Then look
Try it
at
again.
exponent.
Wait, no, I have it. I think I got it.
And you know, like, oh, I got it. Or you're like, nope, I made stuff up along the way.
Or you just like completely miss it.
Yeah, or you just
I already had it.
stuck. Like
you have it, then like you didn't like connect the dots yet. You're like,
I know, sometimes kids beating it up and I'm like, one more step.
I literally
You're
went in a
there.
circle and I was like, what am I doing?
Scenic route. It happens.
Says
Oh, I'm an idiot. I thought it was both opposites, but they're not.
All right, guys. Step 1 is common. Okay. Okay.
I'm an idiot. You should have them as both.
Well, yeah, sometimes half the problem is you wrote it down wrong, and then they don't go well.
That really doesn't work.
No, yeah, I have to discuss it.
I haven't. It's
Then I don't.
All right, common denominator. And that creates cosine squared plus sine squared in your numerator. What is cosine squared plus sine squared? What is 1 over sine?
So cool. 1 over sine is the house line. And that's
See? There was no sarcasm in your house.
No, we should do one day with the late instead of like actual. We should do riddles, like math riddles. Isn't it TED riddles and like these algebra ones? We should do those.
That'd be very fun.
I think that'd be really funny. And oh,
that should be working.
Okay. It's not as bad as it looks. Because I agree, it looks kind of bad. Like,
let's go wing it.
Wait,
That's how many more do we have?
we go to 6.
we're making Damon.
What I got today. 6.
Oh, but there's supposed to be a funny -1 again.
There is that little random minus 1.
Random. That was not random at all. It's exactly what you're doing.
So I get cosine squared x plus
I like this.
squared x over sine x. I don't know where you go from there.
What is cosine squared plus sine squared? Yeah, look at your Pythagorean identities.
So,
This is the first one. Let me say. You just say it. So that's 1 over sine.
Which is cosine.
Decided that I don't.
Try again.
it's not the right answer.
Nope, I do not accept that answer. Try again. There's a few ways you could do this one. Turning it into sines and cosines is not a bad idea. Yeah.
I start canceling. It just makes life so easy. Honestly, I don't even know the rules. I'm just like, if it looks like a rule, I'm assuming it's right.
Oh, like the Pythagorean identities? You're like,
Yeah,
well,
like,
it
if
must
it-
be
If
that.
it looks right, I'm just like, it's probably right.
I mean, that's what I did in geometry. It'll probably work there.
Probably.
Yes, the only thing, do you see how your -1 like disappeared and then came back?
Yeah.
Write it in every step. But yes, good.
I get so caught up in the trigonometry that I forget the minus.
Yeah.
Right, you're forgetting like just the basic calculations.
Yeah.
Yeah.
I don't have enough brain power to like spread it out. I have to only focus.
You're like,
This seems like so much fun.
get it out.
They're so long. It's like so brutal.
What's that? I don't know what that means.
It's okay.
I did it.
See, this is what I'm
All right, guys.
This is how I break things. Finally.
Finally.
Not stupid graphs. That was terrible.
Cosecant squared is 1 over sine squared. Tangent squared is sine squared over cosine squared. Now, guys, it's really easy. That -1, you're not really going to do anything with it for a few steps. You can't leave it behind and have it magically reappear later in the proof. Makes it not a proof, okay? It has to be there the whole way. So write down your -1. These cancel. Guys, what is 1 over cosine squared?
Secant squared.
And secant squared x minus 1 is tangent squared x. Questions on that one?
How is this going to be helpful to us later?
Do you think you will ever have to problem solve in your life or think logically?
Hopefully not. Four.
What?
Can't have any number.
Yeah, you guys were complaining that there weren't enough numbers, so I put 4 in.
That's not what we did.
It's not what you wanted?
You're twisting our words.
I kind of meant like maybe just like a 4.
You meant fewer letters.
Yeah, I think it
We
was like
meant fewer everything.
And then maybe like
Fewer-
plus.
I'll let you try for a minute, and then I'll give you a hint if you're stuck. I would work on the left side.
Okay, so
The side with the 4s.
Would you recommend breaking it up into like cosecant squared times cotangent squared?
Okay.
Ah, I heard difference of squares. Okay, guys, over here on the side, what if I had a to the 4th minus b to the 4th? What would that factor into? Okay, you're gonna need that.
Oh.
And I can't write all the way over there, so you can't read that, sorry. It's actually one of the shortest proofs we do today, if you see it.
Yeah,
One of the shortest.
It is. 2 steps.
Surprising. Aesthetic.
Please, please, please. I want to see it.
Look at your Pythagorean identity.
Like I said, just assume it. Just assume it. Way
better than geometry proofs, right?
Like, you know. I can just make assumptions.
Geometry, you have to like add it.
Right. Angle addition postulate. Segment addition. Yeah.
So when you break it up into like the left one, the one that has minus is 1, right? But then what do you do with the right? There's not a Pythagorean.
I want to do one.
But where are you going?
I swear the receipt that trigonometry ended up happening is some dude just started tripping balls and then broke his.
Oh, wait. Oh, that's all you need to do, right?
Yeah. All right, guys. We factor. It's cosecant squared x minus cotangent squared x times cosecant squared. I can almost write plus cotangent squared. Cosecant squared minus cotangent squared is what? 1. And then you are done. Looked much scarier than it was.
It looked terrifying. That's the part
Guys, just to make sure we're doing it this way, do you notice that I just, what are we doing with the whiteout? Oh my goodness. What's happening? All right, back to the proof. Yeah, sure. Normal day in second period. Make sure you're working vertically down your page. Do you guys notice that I do a step and then a step and then a step? That's what you need to do. At no point should you be doing like this equals this, like working sideways on your paper. No. Vertically down your paper, okay? Just to make sure.
Did it finally run out?
Yep.
All right, cosine squared theta minus sine squared theta. Yep, doing theta.
I wonder if we can like.
Run out of letters.
We go Greek.
Okay, now I'm assuming we're working on the right side.
Oh, no.
I would work on the left on this one.
Isn't there more stuff on the right though? What did you say?
They're kind of equal.
Okay.
You can probably get there on the right as well. Yeah. Look at your Pythagorean identities. All right, I will start this one for you, okay? Let's see.
We can select what side, so we can.
I would do the left. Good.
Is that allowed?
Cosine squared minus sine squared is not an identity.
Yeah, catch up.
It still would work on the left. I'll let you flounder for a moment. Yep. When we get to the Greek letter alpha, I had someone one day just turn it into, they were like, oh, it's a fish. And they just drew fish all over their paper.
Yes. I love that.
When we did logs, they just drew little log fighters. Class didn't go well for them.
Name drop.
Oh.
Now this is from a long time ago.
Name drop.
How do you decide which side to start on?
It's probably one of our moms. Dads.
Intuition.
How old do you think I am? Sometimes it's trial and error.
Maybe it's somebody.
So is it? No, it's definitely not.
The math still doesn't work out.
Did you have any teen moms in your?
I would say the left, but sometimes it doesn't matter. Sometimes it's not really easier on one side or the other. It's just going to take practice for you to recognize.
Generally, the more complicated ones.
Yes. But this one, they're kind of similar, so yeah. Yeah. Like sine squared to the, yeah.
I changed. So I changed the sign.
So 1 minus.
So 1 minus cosine. So then I got cosine squared minus 1 minus cosine squared.
So it was.
Can this correlate to this at all?
Yeah, because it's minus minus. So you're actually adding.
So I added the 1 over here, and then I made this.
Wait, why did you add 1?
Or, because, can I just minus 1 over here and then make this plus?
No. Why do you want a plus 1? Look at what you have right here. You have cosine
I don't want a plus 1, but I was asking, that's not how it works, right?
No.
So, then the minus minus here makes it a plus, and then it's 2 cosine.
There is a minus 1 right there.
Wait, but it's a minus, and then a minus right here, right?
He's writing it. Pulling you, right?
It's not because it's still an interesting thing, but yeah, I think that's
It is.
But,
So you had cosine squared
Wait.
minus 1 minus cosine squared. So that's cosine squared minus 1 plus cosine. 2 cosine squared minus 1.
oh, it's the one minus the oh.
Yes.
You trig sine cosine.
Yes.
They're so high.
I mean, there's appropriately. Use the Pythagorean identity. That's
Oh, you can plug it. Hi.
yes.
I'm kind of dumb.
You have to use some Pythagorean identities here, guys.
Now that you said that, it's so obvious. Okay, so you can plug it in the other way.
Are we ready, guys? Okay. That's okay.
I get more these are just like put a book on the board.
Yes.
That's cool.
They're fun, right? There's one more. Did you get it?
Wait, no, I don't even know what it is. Yeah.
Listen, okay, I was like, oh no. I understand. I'm glad it's finally Friday. One more week.
When you plug it in your friends, there's a negative there.
Yeah. There's so many things you could start with that you're like,
Some ways are just better
Some ways are faster for sure.
Look at this. You need to look at it like what is sine? Make it sine. Sine taking this to 1 minus
So if they're drastically different, like one has a whole bunch of stuff and the other side has one term, you want to go a whole bunch of stuff because then you have something to work with. This one, they're kind of equal, so it's a little trickier. I mean, you could do, I'll do the left side and then I'll show you the right side too. You could actually do either. All right, guys, on this one, I'll start with the left side. You can replace sine squared with 1 minus cosine squared. Then it's just a matter of distributing your negative, and you get minus 1 plus cosine squared. Cosine squared plus cosine squared is 2 cosine squared minus 1. Now, did anybody try to do the right side? It should work. Let's see. Instead of cosine squared, I could do 1 minus sine squared, although that's going to be ugly because we lose our cosine squared. Left side is definitely easier. Ooh, we could do this.
Is this an example of taking the long way?
Just different way. You could do that. Replace the 1 with sine squared plus cosine squared. Yeah, and then 2, you see, you'd have 2 cosine squared minus sine squared minus cosine squared, and then you're done. So
It just depends on how you think.
that's another way to write 1, right?
Oh, it is.
So yeah, it's not that much worse. Really, it's whatever your brain sees as the way, well, it's usually the way to go. Yeah. 2 options there. Number 6 that we're going to do, you could definitely work on either side as well.
Yeah, that's pretty good.
All right, tangent of x times sine of x equals secant of x minus cosine of x. You can get there either side.
Wait, this is the last one. Yeah. Okay, you know what? Other side. Thank you.
How are we doing, guys? Not great? Okay.
So cool. That's so
You made it?
Yes.
Yay! It's like so satisfying when you get to the end. You're like,
So close, but like so far.
oh!
I understand.
I'll give you guys a few more minutes before I show you.
I'm like,
I know. It's gonna be a good skills for you.
yes. This is what I was looking for. The first half looks scary. This is actually fun.
Yay!
It's great.
Yeah, when I flash to the screen of like Pythagorean identities.
Seriously, no. How you doing? Sounds good. Really? Suck it.
I'm so close.
You're so close.
I'm so close.
We each have one time though?
Are we ready, guys? So close. Oh, okay, you got stuck.
I'm so pointed.
Did you guys pick left or right? Did anybody? Anybody do right?
You're right.
Yes, I did it right. I did it right.
Oh, okay.
Well, you guys did left. Yes, I did it right.
Which side did you do? Left?
Right, you did it right. I did it right.
Okay. Right side is common denominators.
Yes.
Left side
Better way. Better way.
is sine and cosine. I'll do both, okay?
Nice haircut, man.
All right, I could rewrite as sine over cosine times sine, which gives me sine squared. Okay. Sine squared is 1 minus cosine squared. Yeah? Will. Yeah? There's people. No way, people. Does that make sense? Okay. Then I could break this into two fractions, right? I could do 1 over cosine. That's a step you were missing. So that is secant minus cosine. Okay. If I did the other side, I'll do that one. So secant I could write as 1 over cosine. Then I need a common denominator, and I end up with 1 minus cosine squared over cosine.
And then
Then that is sine squared over cosine. Then you split it. Yeah, you split it into sine over cosine times sine. Are you guys okay with that step? Sometimes that's a tough one for people to recognize.
What is the better side of this?
There is not a better side. The better side is the one you understand.
Okay. Right. No, the left. Stop. The left is the bad side.
Okay.
The left.
I mean, look at them. They're about the same. All right, guys. Question. Okay. Let me get your homework to you. It is on MassSpace. I know. But I will put like some practice ones up here if you want.
I'm gonna do it during work time. Like, I'm gonna like.
These are just practice if you want some.
Yes. Oh no. What is
I didn't
that?
say they were easy practice problems.
I can't even see.
Okay, I'll make it bigger. Your homework's coming, guys. Yeah, give me a second. Let me click assign.
Oh yes, you gotta. I'll try and remember it.
Okay. All right, guys, MathSpace has been assigned to you. This is just some extra practice if you want to try some. Can you see that? I'll post this on Schoology too.
Oh, I see.